Okay, so guys, in this video, we are going to solve some examples related to the second derivative test in which we have to determine the relative extrema. So the first function is 1 minus x cube. Okay, so let's take the first derivative as a first step of the second derivative test. So the final derivative is negative 3x squared. Now for the second step, we have to let this thing equal to 0. So 0 is equal to negative 3x squared. The value of x will be, first of all, we will divide 3 on both sides. So negative 3. X square would be equal to 0 divided by negative 3 is 0. It will be 0. Now the third step, you have to find the second derivative for negative 3x square. The derivative of negative 3x square, first of all, negative 3 will be separated, and then the derivative of x square will be 2x. So negative 3 times 2 will be negative 6x. So this is the second derivative. Now this is the critical point, of course. First of all, let's just make this second derivative equal to 0. So of course negative 6 will be divided, negative 6, and x will be equal to 0. So this is the inflection point. The question arises, how can we determine the relative extrema, i.e. the relative minima or the maxima from these values? Because we only have one value of x, okay? So I know that's already a problem for us because we need to have two values of x for determining the relative minima or the maxima. On top of that, the second problem is that the value is nothing. The value is actually 0. And when something is equal to 0, I told you in the previous lecture that when the first derivative of x is equal to 0, this condition is known as the inconclusive. So the result is actually inconclusive. We are unable to calculate the relative minima or the maxima from this second derivative test, or you can say the concavity test. You can put this value of x is equal to 0, the critical point, into the original function. You can put f0 is equal to 1 minus 0 cube. So now what will happen? We will have 1 because 0 cube is 0. So at the value of x, the function has a value 1. At the value of 0, the function has a value 1. This will be my x coordinate and this will be my y coordinate. So we can plot a graph over here and we can locate this point on the graph. So if this is 0, this thing on the y-axis is 1, so this will be the point. There are two conditions from over here. Graph can either open upwards or the graph can open downwards. So we can say that this point 0 and 1 can be the maxima or the minima for this function, but we cannot be specific about what is the actual maxima or the minima for this function. Hey, this is me from the future. One thing I forgot to mention is that of course we were unable to determine the value of the relative maxima or the minima for this function and the result was inconclusive, but we can actually put the value of critical point into the original function, and by putting that we get the value of the function at 0 equal to 1. This point is known as the saddle point, and by doing this we can actually get some information. We can tell that the relative extrema is existing at this point, but yeah, still we cannot determine the relative minima or the maximum. Now the second function which we have is 5x squared minus 6x plus 2. So for the first step, let's take the first derivative. So the derivative of 5x squared will be 5 will be separated 2x, derivative of x squared is 2x, minus 6 will be separated, derivative of x is 1 plus 0. So 5 to the 10x minus 6. So this is the first derivative. Now let's make it equal to 0. So 10x minus 6 is equal to 10x. We can just simply move this 6 toward the opposite side of the equation. So we have 10x divided by 10 on both sides. So we'll have x is equal to 6 divided by 10, which can be written as 3 divided by 5. Third step, we have to take the second derivative. So f second derivative of x. So the derivative of 10x will be 10 and the derivative of 6 will be 0. So this is the second derivative, and of course the value of the inflection point, this is the critical point, and the inflection point does not has any value. So if the inflection point or the critical point is not having any value, it is equal to 0. So we can say x is equal to 0 is my inflection point. Now I told you that inflection point is actually not really important, so we can simply ignore it. So now the second derivative test is 10, right? So 10 is actually greater than 0, right? If something is greater than 0, the graph will be concave up. And if the graph is concave up, this will give us the value of minima. So what is the minima? Is the critical point, of course. So our critical point is 3 upon 5. Put in this critical point into the original function. So we can simply put in 3 over 5 in this function. So we will have 5. So 5 times 9 divided by 25, which can be cancelled out by the 5 over here. Minus 6 3s are 18 upon 5 plus 2. So we can quickly take an LCM, and by solving for this function, you will get 1 upon 5, which will be the saddle point for this function. Okay.